Hello, and welcome to the Reliatest software demonstration video. This video will provide a brief overview of the ILX Lightwave reliability test system's capabilities utilizing our Reliatest software. The very first window that shows in Reliatest at boot up is the Rack System View, which can be seen in the right-hand panel of the screen. The device view on the left hand of the screen shows us currently configured devices. This allows the user to enter device parameter limits, such as current limits, monitor photodiode current, laser drive voltage, fixture high temperature, fixture low temperature, and whether or not to turn off the current sources in an adjacent position. Once a device is configured, the operator can build different test configurations. A test in Reliatest is defined as a test parent, which is associated with a device type and allows the operator to enter up to 4 optional informational slots. In this ramp soak example, we have an initial LIV for a device with a start current of 0, step size of 1 milliamp, and end current of 125 milliamps. The next section is the temperature control. This specifies the temperature at which the fixture will perform the LIV. It also shows the temperature window and tolerance settling period. One of the benefits of having a real-time graphical display is that the operator can go in and investigate device failures, fixture failures, and make sure everything is running correctly. Whether a test is running can be seen via graphical colors for the icons. For example, a test is currently running in this zone, and so it's green. On the right-hand side, there is a color legend that shows all the different colors Reliatest will display based on occurrence. For example, if an error occurred, there will be a red indication flashing on the fixture. An operator can read real-time temperature of the fixture. You can also see the serial number for the fixture and the device type. You can also click on the running test, which will be selected in the test view on the left. When you access an individual device, you can see information related to that device. For example, the laser drive output is off for device 11, and burn-in measurements will provide an instant real-time feedback to the user of measurements that are being collected. Performing a burn-in measurement allows users to take a quick instant measurement of the set point drive current, voltage, monitor photodiode current, external photodetector power, and the fixture temperature. It also displays the limit of each of those parameters as configured in the user's device configuration. We now have a device that we have specifically failed, and we also have a device that we failed but left on. Hovering over the device provides a little more information regarding the failure itself. Additional information is provided by clicking on the test parent and viewing the test event. By navigating up, you go back up to the rack view. Anytime you access a fixture or a device, you can navigate to the next incremental device or fixture, decrement to the previous device or fixture, and go up one level. To view data, you can right-click on a fixture that is running a test or has just recently stopped a test and click View Data. Or you can right-click on a test of interest and click View Graph. You can also add multiple tests to the same graph so you can overlay them on top of each other. Here is an example of a typical LIV. This LIV was run on a subset of devices starting at 0 milliamps going to 100 milliamps with a step size of 0.2 milliamps per step. It was run at 95 degrees Celsius. The axes are enabled for external photodiode current and laser diode drive current at the X-axis. Here we can see the typical threshold current for these devices are between 32 milliamps and approximately 40 milliamps. You can zoom in on some of the device threshold points on the graph by clicking and dragging a box around our desired location to zoom in. Here you can hover over device 4 and see that the single line is approximately between 31 and 33 milliamps. If we zoom in and select only one device, we can pinpoint the threshold current. So we have about 32.24 milliamps where the threshold starts. You can also double-click the axis and either enable auto-scaling or change the number of significant digits that are being displayed on the axis itself. One of the ways to pull data out of the system is to right-click on the test parent and select Export to CSV. You can select the standard CSV export, which is typically used. There are more advanced options, such as exporting cumulative tags or doing a combined data export. Here is an example of the CSV export file from Reliatest. This CSV export was specifically for a 1 hour, 45 milliamp set point burn-in at 95 degrees Celsius. The CSV data contains the test name, fixture number, CMM IP address, start time, and finish time. This fixture was not calibrated for external photodetectors, but it did have an external photodetector array. The test parameters were 1 hour test measurement intervals every minute, drive current set point of 45 milliamps, temperature set point of 95 degrees Celsius, and 0 volt monitor photodiode bias. Data for each device is put into a subset of columns. For example, here is the data for device 1, device 2, which failed before any data points were taken, device 3, all the way to device 32. If a device fails halfway through the test, or after data points were collected, those data points will be shown here or visible in the CSV. That concludes our video. Thank you for watching our intro to our Reliatest software and a few of its many features. For additional information, please contact sales@ilxlightwave.com.